Hi and Assalamualaikum everyone. We are from Group 1. As you can see on the screen, our topic today is nuclear physics. Our group consists of 4 members, which are Muhammad Imran bin Cik Murad, Nur Syairi, and myself, Nur Afina Fitriya bin Tasmini, and Farid Daniel. This is our presentation content. First, introduction. Second, properties of ionizing radiation. Third, radiation detection. Fourth, radiation accident. Fifth, application of nuclear physics. Sixth, radiation safety. And seventh, conclusion. For the introduction, X-ray discovered by the German scientist Wilhelm Röntgen in 1895. Radioactive radium discovered by French scientists Marie and Pierre a few years later. The different forms of radiation around us seen in the electromagnetic spectrum below range from radio wave low energy to gamma rays high energy. Next, we move to the two types of radiation. First, ionizing radiation, wavelength shorter than 100 nanometer, for example, X-ray and gamma rays. Second, non-ionizing radiation, wavelength longer than 100 nanometer, for example, microwave and radio wave. Now, we focus to the properties of ionizing radiation. Ionizing radiation occurs when an electron in the inner orbit of an atom receives sufficient energy to escape from the influence of the nucleus. It will cause the formation of a positive ion and negative ion happen. As a result, X radiation is emitted when an electron from an outer shell falls in to take the place of the electron that was ejected. Ionizing radiation 2. Alpha and beta particles, gamma rays, and X-ray cause ionization when they pass through matter. They are emitted spontaneously from the nuclei of an unstable atom during radioactive decay. Ionizing radiation 3. X-rays are produced by the sudden declaration of the electron in the strong field of the target nucleus. X-ray machines emit radiation only when the machine is energized. When the high voltage is disconnected, no X-rays are emitted.
And I will continue to properties of alpha, beta, and gamma radiation. For alpha, the characteristic is strongly ionizing, have a strong positive charge, and a mass of 4, same as helium nucleus 2 protons and 2 neutrons. For beta, it was strongly ionizing. Perhaps one beta particle will cause 100 ionizations, called beta particle, to identify that they came from the nucleus of the atom. More penetration than alpha particle. Okay, for gamma, it was very poor at ionizing, about 1 to 1, but very difficult to stop, very penetrating. They are not good ionizers. They are less dangerous to life. Okay, the next part is a radiation detection. The first one is portable radiation monitor. A battery-operated handheld meter like Geiger counter and scintillation counters, used at radiation facilities and work sites to ensure that the radiation level is within its limit. Consists of probe containing the detector, GM tube, ionization chamber, or detecting the head and the associated electronic circuitry. It must be calibrated at periodic intervals in a radiation calibration facility. Second is area radiation monitors. It was to give an indication of the external radiation levels present in an area where there are ionizing radiation. If the level exceeds a predetermined value, it sounds an alarm. Usually are designed to respond a gamma radiation.
Next part is radiation accidents, that defined as a situation in which there is an unintentional exposure to ionizing radiation or radioactive contamination, which exposure may be real or suspected. So, situations that may be classified as radiation accidents. First one is nuclear power plants. It has the potential to release radioactive materials into the environment that cause widespread exposure to radiation and various health effects. The second one is industrial accidents. If proper safety protocols are not followed, Accidents in industrial facilities that deal with radioactive materials like research laboratories, nuclear fuel processing plants, or sites for radioactive waste disposal can lead to radiation exposure. The third one is medical radiation accidents, which the mistakes in medical procedures that involve the use of radiation, such as radiation therapy or diagnostic imaging, can result in excessive radiation exposure for patients or healthcare professionals. Next part, we're going to talk about application of nuclear physics. The first application used in nuclear physics is smoke detector. Radiation is released and used to detect the attenuating presence of smoke. Radiation is also used to sterilize laboratory equipment and disposable hospital equipment. The second application is radiotherapy, which radiation therapy involves the application of ionizing radiation to treat conditions such as hyperthyroidism, thyroid cancer, and blood disorders. It may also be used as part of curative therapy, which to prevent tumor recurrence after surgery or to remove a primary malignant tumor. The third application is medical imaging. Nuclear medicine uses radioactive material inside the body to see how organs or tissues are functioning for diagnosis or to target and destroy damaged or diseased organs or tissue for treatment.
So next, I'm going to tell about the radiation safety. Radiation safety, there is three basic rules. First is time, second is distance, and third is shielding. Firstly, time. Time is simply refers to the amount of time you spend near to the radioactive source. The longer the exposure time, the more radiation exposed to the brain of the physician. The second one is shielding. To shielding yourself from the radiation source, you need to put something between you and the radiation source. The most effective shielding will be depend on what kind of the source of emitting. Some radionuclides emit more than one kind of radiation. Shielding devices such as caps, lid glasses, thyroid protectors, aprons, radiation reducing gloves, and so on. So this is a type of radiation emitting. Alpha is the lowest emitting radiation because it cannot penetrate a piece of paper. Second, it is beta. Beta cannot penetrate the lid. But finally, gamma can penetrate all of the obstacles in front of it. Lastly is distance. Distance refers how close you are to a radioactive sources. A greater distance from the radiation source can reduce the radiation exposure. Double the distance from the radiation source can reduce the radiation exposure not to 1/2 but 1/4. So the last part is conclusion. To avoid any accident related to radiation, we must comply with ALARA rules, which mean as low as reasonably achievable. It is used to ensure the safety of employees and the patients. We also have to follow the procedure to keep the risk of radiation as low as possible. So that's all from me. Thank you.